Hello, hello. Did you join using your presenter's invite? Why has it got you locked out? I'm going to let Luke and Saj in. Allow mic, allow camera. Okay, Alain, you should be live.
I still don't have sharing. Can you turn that on, please?
Yeah, that's weird. I wonder why that's not happening. Saj, I'm just going to turn on your mic and your camera, and same for you, Luke. Okay, Alan is here.
Hey guys.
Hey all.
Hello, hello. All right, let's just see what we can do about this presenting business. Saj, how are you?
Very good. Good morning, guys. Can you hear me?
Hi, Saj.
Loud and clear. Reading options. Let's have a look. Specific people. All right, I'm going to manually add you guys as presenters. So, Saj. Are you driving any slides, Alan?
No.
Okay.
I'm going to be doing a quick introduction to both the speakers today. I'll also be talking a little bit about what we're going to explore today, just like in the invite, right? And then what I will do is hand it over to Saj to take us through the first 40 minutes. Then we have then I'll talk after Saj is done. I'll then take a pause, give everyone a 5-minute break, right? Then we'll come back in 5 minutes and we'll move over to Alain and talk a little bit about the business components. At the end, I will talk a little bit about, just wrap up a little bit what we talked about. What are the next steps in terms of if you'd like to contact us, you can. But then other than that, we'll be sending out a little bit of survey around feedback, etc. Right? And that's it.
Could you just try sharing now, Alain, and let's just see if that goes up on screen.
How's that?
Nice. And Saj, do you want to just do the same from your end, make sure that's working as well?
Sure. Yeah, turn on computer sound.
Can see an Agile Factory slide. All good?
Okay. 1 second. Can you hear audio? 1 second.
Yep. Oh, is there?
Yeah.
Audio coming through?
Yep.
It is.
Yep.
Okay, got it. Great, thanks.
Very good. All right, we're at 10. Everyone happy for me to start letting in the delegates?
Yep.
Okay.
End them in.
Yep.
Welcome, everyone. Give everyone another minute before we kick off today. Just one more minute. Alrighty, guys, I think we're bang on time, and thank you everyone for joining our virtual roundtable for executives with Microsoft and LAB3. Today, Microsoft and LAB3 will be exploring how technology is empowering and disruptive approach to manufacturing. Today we have two amazing speakers, one from Microsoft and one from LAB3. And I'll introduce those speakers here today. But before we start, what I would like to say is that today's session will be recorded, so I hope everyone's okay with that. And I just want to say that before we hit the record button, but today's session will be recorded. So Kumar is a Microsoft regional business leader for manufacturing and responsible for developing and driving adoption of next generation industry solutions for Microsoft across many segments, including high-tech, industrial machinery, aerospace, and chemical manufacturers. So thank you, Saj, for taking a little bit of time today to talk to all of us a little bit about this key area. We also have Alain Blanchette. He's a director of data, IoT, and AI, and brings deep experience across complex mining and manufacturing transformation projects, a 25-year industry veteran. Alain's focus is at the center of the IoT and AI technology ecosystem, helping organizations uncover savings, scale, capacity, and profitability. What I will do for the first 40 minutes is hand over to Saj to talk a little bit about where Microsoft is seeing the industry going, and then we'll take a 5-minute break, and we'll allow Alain to talk a little bit about how LAB3 is really working to achieve those things that Microsoft is talking about. Over to you, Saj.
Hey, good morning, everyone. And Alain, thank you very much for the kind introduction. I'm Saj. I'm based in Singapore. I cover manufacturing for the region. And we'll talk about agile factories today. There is the opportunity for Q&A in the chat in the live Q&A section. So we'll take questions as they come by, and I'll try to answer them towards the end of my talk. Let's start off first with where we are heading in terms of vision. I know the term metaverse is very popular, and we announced the industrial metaverse, which for us is very real, very actionable, with all the right ingredients. And this was announced during Build earlier this year by Satya Nadella in his keynote, along with our partner and customer, Kawasaki. So let me play the video, and hopefully you can all hear the audio.
日本では我々ロボットを開発する人間にとってやはり子供のように親である我々開発者がちょっとしたその動きのおかしさにどれだけ気づくかってことは極めて大事な形で、ロボットは実は止めちゃいけないんですね。ロボットはずっと働き続けないといけない、そういう使命を持ってますね。
現場でトラブルが発生した時ですね、生産が止まってしまうという、そういったシステムの検討というものが非常に大変です。
Agileパーセプトを活用して今まで気づかなかったような故障であったりトラブルっていったものや予兆っていったものに気づけると考えております。利点としましては遠隔地の方にエキスパートの方がいてくれるだけで一つの作業現場に技術力であったり知見っていったものを流すだけではなくて複数の作業場っていったところに提供できる点だと考えています。効率的に遠隔から作業支援が行え、即時にトラブルシュートを迅速化するといったところで顧客の安全性を高めていこうと思っています。
それが、デジタルツインの世界ができますと、実際現場に行かなくてもそのトラブルの状態が手に取るように分かってそこでもう直すことができると、そういったものがですね、仮想空間の中で全部調べれるようになります。
完全なるメタバースの世界は開発から設計ないしは試験までの全ての工程っていうものを仮想環境上で実行できます。
川崎重工もですね、 マイクロソフトさんとパートナーシップを組みながら、その技術をバックボーンとしてインダストリアルメタバースの世界をぜひ一緒に実現していきたいと考えています。
So for us, the metaverse is everything that touches the physical world, how you synchronize with it, how you model that physical world, whether it's a manufacturing plant with robots in them, or whether it's a brewery, or whether it's a food and beverage manufacturing company, how you monitor the data, how you track and analyze the data, how you can predict potential problems and run autonomous control, and finally, how we do interact with that. So every element, we have areas that we've been developing products for the last so many years. Of course, HoloLens being the most popular from an interaction perspective. But if you look below the HoloLens from a device perspective, with the Power Platform, with Azure AI, with Synapse, with the indoor maps, with the digital twins, with the IoT components, we are able to stack all of these elements to create the metaverse in the industrial arena. And there are many such examples of customers we're working with in many industries. But when you look at manufacturing overall from a Microsoft perspective, bear in mind that Microsoft is also one of the largest manufacturers of consumer electronics devices, Xboxes, Surface devices, etc. And we also make high-end servers that go into a data center. So we understand manufacturing as an exemplar and also as an enabler of our customers. So when we look at these 5 areas that we want to drive in a manufacturing company, from the workforce transformation, especially with the aging workforce, post-COVID workforce transformation, rapid skilling enabling, getting younger people into the workforce, that is a big challenge for many economies around the world. The second one is customers. How do we kind of drive customer engagement, whether it's B2B commerce, whether it's field service, whether it's connected products? All of these are areas that we're looking at in terms of customer engagement. The third one is supply chain, which of course became very visible during COVID and also post-COVID with all the challenges in logistics and raw material supply, particularly now with Ukraine, we have a lot of raw material issues. So how do you kind of manage the supply chain better? Then the fourth one is how do you kind of make more with less, the agile production area? How do you manage your plants efficiently? How to drive workforce productivity? How do you keep your machines up? How do you ensure quality? And then lastly, we cannot forget innovation. So the whole area of R&D, driving virtual desktops for R&D engineers to moving CAD and design workloads to the cloud, moving research innovation to the cloud. These are all areas where we believe there's a lot of potential. And of course, right at the bottom is sustainability that drives across as a digital thread throughout the entire cycle. So I'll focus today on agile factories and manufacturing, and what we are kind of heading towards now maybe 5-10 years is the whole area of lights out manufacturing. So plants typically, you'll have a lot of sensors, a lot of data coming in. You may have a control room, you may have a SCADA control system. You also have operators who have field knowledge, who listen to equipment, who can see the sensors, who can actually look at the equipment performing, capture data on paper. You have video feeds, all of this data that's coming in, a lot of it is unstructured. How do you kind of make sense out of that into a standard integrated manufacturing data model, and then drive some machine learning outcomes out of that, which of course will eventually lead to what we're calling lights out manufacturing. Today, the operator is consumed by operating the plant in those safe operating parameters within certain KPIs that are driven by maybe some process control settings. But what we really want to drive is, can you push the boundary to making sure that every action that he takes is actually driving a profitability goal or driving an EBITDA goal, where you want to make sure that you're pushing the envelope in terms of operations, at the same time keeping the plant safe. So one of the other examples is Unilever, where we started working with them a couple of years ago through a company called the Marsden Group, who we acquired last year. And Marsden created digital twins for their Unilever plants, starting from very old plants in Africa all the way to the rest of the world. So roughly about 80 plants today, heading to about 300. So the idea is to create twins of these plants and ensure that the reliability of the plant is consistent across sites, and the quality is consistent across sites. and you don't need to have an expert operator come to the line every time you need to change from maybe shampoo A to shampoo B or something, or some other scenario that exists in the plant. So which is where we're creating these offline scenarios or offline models where they can actually literally model this plant in the digital world, and then try to push these settings down to the control system. AB InBev is another public story where we've actually done this while looking at the fermentation process and trying to keep a consistent fermentation level. A lot of manufacturing, even in very specific, discrete manufacturing scenarios, is a lot of art and science. And the art depends on the experience of the operator. The guy who looks at the fermentation process, he can look at the color and he can tell you when the fermentation batch is done. So this is where, how do we kind of improve upon this, and how do you make sure that we have the consistent quality even when you have change in operators, a change in location, or change in equipment. So this is where I want to play a video again of the work we've done with AB InBev.
With more than 200 breweries and 160,000 employees across the globe, Anheuser-Busch InBev is the largest brewer in the world, paralleled portfolio of brands, and a global presence with operations in 50 markets. AB InBev is an expert in their field, and their forward-leaning and innovative spirit is leading to new breakthroughs in brewing. Through their digital factory and supply chain of the future initiatives, in collaboration with Microsoft, AB InBev is focused on transforming both breweries and their global operations by empowering their frontline colleagues with digital solutions that enable world-class manufacturing, mobility, data automation, and business insights. It begins with the brewery coming to life with AI, Azure Digital Twins, and the Microsoft Cloud. The brewmaster is responsible for making the best quality beer. She has unprecedented visibility into the brewing process, so she can predict and monitor the complex chemical and biological fermentation parameters required to produce the highest quality product. Frontline operations can remotely monitor critical quality and traceability data from the manufacturing execution systems using the mobile brewery technology built using Azure. With built-in energy and utility management solutions, the digital brewery supports AB InBev's industry-leading sustainable development goals. After the perfect batch is ready to be bottled and shipped, AB InBev extend their digital twin solution to support the packaging line operations to ensure it's done right. These can plans are adopting Azure AI and Microsoft Project Bonsai's deep reinforcement learning to deliver line balancing optimization that detects and automatically compensates for bottlenecks in the complex can manufacturing operations. At AB InBev, their 100% uptime mindset is enabled through predictive maintenance and global support. A frontline operator can efficiently address problems through remote collaboration with a maintenance technician, ensuring no unplanned downtime of packaging equipment. The perfect beer is packaged and ready. The digital technologies of the AB InBev supply chain of the future minimizes carbon footprint while making sure the right beer gets to the right customer at the right time. This beer's journey is complete, and AB InBev and Microsoft are taking bold steps into the future.
So what you saw was the ability to kind of create 3D representations of surface models of the equipment, the indoor maps, and then of course embed sensors into these dashboards showing you live data, 2-day data, 3-day average, one week, and also kind of play a simulation of how the data moved through the last 1 week, last few days, etc. Showing you the color changes in the fermentation tank, as you may have noticed. So when we look at this whole thing, the way we crafted this was try and look at it from 6 different perspectives, maybe top down from an asset, from bottom up from a people, and maybe security is both an asset and people side, is the whole automation area, which of course has largely been done in many companies, right? You know, you have the level of automation, you have the level of connectivity. Maybe some older machines have not been connected, and then moving into the twin modeling area, The second one is how do we get into autonomous operations? Not the entire plant, but can parts of the plant be run autonomously? We then look at the whole idea of maintenance, moving towards prescriptive maintenance. And then the people side, how do we move more work in an automated way as opposed to pushing paper or voice instructions or other non-digital forms of communication. And then we have the digital worker through which we can provide devices, HoloLens being one of them. And lastly, the aspect of security, making sure that you have complete OT security with all your assets, machines, sensors, etc. And that drives, of course, your manufacturing data estate and then driving machine learning outcomes. So when we look at the automation and digital twins, everything from the physical plant to the warehouse to warehouse robots to AGVs. So all of these areas are kind of where automation is playing a huge role uh, with many factors, right? Lack of talent, trying to drive productivity, in some cases, distancing requirements where you can't have too many people. All of these things are kind of driving the whole automation area. And we look at this, we look at this from three different phases in terms of how this is moving. From a connected phase where you start connecting to PLCs, the edge gateways, get the telemetry dashboards, look at what's happening. Then we move into the predictive phase, which we see maybe like about 20% of companies doing this in parts of the plant. So it could be predicting rotating equipment failure by monitoring vibration data, for instance, could be monitoring heat exchanger fouling by looking at the pressure drops, for instance. So it could be looking at boiler tubes, a lot of areas that you could be looking at trying to drive predictive outcomes. And the last one is cognitive, where we try to get into more self-optimizing, self-running, self-healing systems, where we're looking at uh, different business models in some cases, right? So this is where we see maybe a small percentage of customers in that bucket. So when we look at this area, the first thing is, of course, what can we do from a remote operations rewind replay perspective? So this is where I talked about the Unilever example of how you can look at plants from a central dashboard. You can look at comparing maybe a cookie plant in one location to another location. Look at equipment performance. All of these things can be done. Golden batch is one example how you want to maintain that particular batch that gave you the best quality, and rewind and replay scenarios. So when you look at the twin, it is a term that's often used, but it means many things. In the old days, of course, the twin was always like a simulation twin. You would have an Airbus simulator, you have an Apollo lunar module simulator. So these are all kind of simulation models that exist for digital representation of assets. Then you have, of course, the asset twin, which today is captured largely in your ERP system. You have a performance twin, which is looking at data coming in from the turbine, for instance, maybe a GE turbine, and then trying to understand the performance of the turbine. You could have a configuration twin where you have configuration managed in a plant maintenance system that gives you A, B, C, D type of configurations for different assets as they exist in the plant. And lastly, probably the most important area is the entire process. How do you run a process control twin of a complete, maybe a power plant or a beer manufacturing plant or any plant? And that's where it gets very complex when you want to get everything together into one single model. A very high level architecture. These slides, of course, will be given to you so you can have a look at this, how we differentiate between the edge and the cloud. So obviously the red line here is the line that separates the edge from the cloud. So you have all the edge components, the artifacts that pull in data sitting in a container on the edge. So this could be a small box, could be a big box, depending on the type of scenario you want to run. Of course, supports OPC protocols. Microsoft's been part of OPC UA for 25 years at least, contributed significantly to the OPC code. We also have on the right-hand side all the IoT device management. We have your hot, warm, and cold path analytics, and then of course on the right-hand side all the products that you might go into, whether it goes into an ERP system, goes into Dynamics, goes into Power BI for analytics, goes into IoT Central. So this is where we kind of manage the entire data that's coming in from the edge to the cloud. And of course, there could be scenarios where you might take data from the edge, mash it up with ERP data, quality data, plant maintenance data that gives you a data model that allows you to then start understanding interrelationship between a process parameter upstream to a quality parameter downstream. We then move into the second bucket, which is autonomous operations. And this is where we realize that there's a huge gap between classic AI versus what you want to apply in an autonomous manner in a plant, whether it's a reactor, whether it's a CNC machine, etc. So let me play one more video.
70% of the world's water, 30% of the world's energy goes into the production of food. And at the same time, 30% of the food we produce is lost or wasted as it travels across the value chain. So we set this target to reduce energy consumption and waste by 30% in our customers' value chains. And digitalization is an enabler of that.
Bühler is a family-owned Swiss company, the world's leading supplier for solutions in the food processing industry. Bühler Insights is a cloud-based platform. Leveraging the power of IoT, machine learning, and AI, we're able to provide operational efficiencies, cost savings, and most importantly, better products than ever before.
Beneath the umbrella of the Bühler Insights platform, we have a portfolio of digital services. Our optical sorting technology uses sensors to take a snapshot of the grain. We split that image up into pixels and analyze each individual pixel. Image processing techniques and algorithms make the decision whether that pixel is good or bad. Then we can eject the defect. And all of this happens at industrial grade throughputs of 15 tons an hour.
Smartphone technology to analyze sample and enables our customers to make accurate measurements of the material running on their process line to maintain optimum efficiency. We use machine learning to aggregate activities from all of our social media channels to give our customers really early intelligence on a food safety outbreak in their sector.
Today, we're working on technologies like blockchain. We have problems with food authenticity, traceability. Consumers are demanding more transparency of the food value chain. And blockchain is an enabler to make this happen. Microsoft and Bühler have a common goal to make the world a better place. And it's this shared mission that truly bonds us in this journey together.
So that was an example of what we're doing with Bühler in terms of real-time analysis of grains, trying to identify carcinogenic molds, the aflatoxin, for instance, in this particular case, and trying to do that with the LumoVision, which is basically an optical sorter that uses edge AI to analyze the grain in real time. We also have done work with machine teaching, and this is where we look at the gap between a domain expert and a data scientist. A domain expert being somebody who's in the plant, the subject matter person, and the data scientist. So how do you translate that knowledge? And that's where we see a lot of POC starting, but never really get to a production level, fruition. So this is where we're looking at machine teaching, where if you look at an example of baseball or soccer or any game where you might use machine learning to make a kid watch TV for a few hundred hours and hopefully he picks up something. But the machine teaching approach is to use a subject matter expert, the same person who's running the plant, and allow him to use a low-code framework to build the machine learning model. And that's what we're trying to do with machine teaching through one of the acquisitions we made 3 years ago called Bonsai. An example of this is work we're doing with Pepsi Foods. I'll play another video.
What makes the perfect Cheeto? Precision. The right ingredients, the right size, shape, flavor, air, coming together to make the perfect crunch. It's really important that our Cheetos are in specification each time. We've partnered with Microsoft and Neil Analytics to deliver the perfect product to our consumers. Our engineers know how to make a Cheeto. They understand the day-to-day, what the machine looks like, the vibration, the pressure. They take all their knowledge and train the AI. Then they assess how the AI is making decisions through millions of simulations. After we've trained it on all these different parameters, it's continually tracking the performance coming off our extruders. It flags real time if there are issues so we can intervene very fast. And what's great about the autonomous systems is that it upskills our workers. It's actually the perfect combination of human and machine. Our trial runs have all been successful. Now we're starting to scale. Innovation is such a core value for PepsiCo, and Cheetos is so integral to that. We wanted to make our consumers happy with every experience, and autonomous systems are going to help us raise it to the next level. We're just getting started. We're ready to rock and roll.
So that was an example of what we did at Pepsi on food extruders. So autonomous AI is not broadly applicable to every plant, and certainly not across the entire plant. We're looking at specific areas. So food extruders is one. We've done some work in CNC machines. We've done work with chemical reactors. So specific processes that can be simulated well. Then we use a simulation model to actually then get the operator to do these inputs and changes, and then see whether the actual DRL model that's being created is able to replicate what's happening in the real world. And that's where we start fine-tuning it to then eventually push it to production. Vision AI is another area where we're doing a lot of work. So one example is, of course, looking at the shipments area, making sure that your shipments are accurate. You have sometimes a lot of mismatch when you have multiple pallets loaded for the shipment. So you want to have an alerting system that looks at all the boxes that are in the pallet. You have a camera that's connected that identifies from the barcode what was in the particular pallet, connects back to maybe your SAP or some other ERP system that tries to identify whether the right boxes have been loaded on the pallet, and then allows you to have a high degree of accuracy in dispatch, right? So this is where you're improving the product, improving basically the accuracy of shipment, and relying less on the human to check the barcode and making sure things are going to the right location. Another example in manufacturing or even in retail could be using the camera to look at labels, label alignment, wrong orientation, print. So this is, of course, can be done in high volumes. When you have a high production line, you want to have a camera. So the Azure Percept Edge Vision AI capabilities allow you to take those images, analyze them, and see whether they are in the right orientation, the right date, the right serial number, etc. So next area is the maintenance aspect, which of course will be covered in a lot more detail by Lab3. I'll just touch upon high level in terms of the things that could be done. So obviously in the area of vibration, sensors are very important. Most plants do not have multi-axis vibration sensors. So again, it's not just the multi-axis, it's also the frequency at which you want to acquire the vibration data. Especially if you have slow moving equipment, you want the high frequency analysis. You want to make sure that you're not missing out those spikes that may happen when you are not analyzing data at that level of frequencies. Again, different types of boxes to get the data in, moving into an expert diagnostic system, comparing that with a data lake in terms of all the different vibration patterns you might have for a piece of equipment in a specific service, and then coming back with an advisory portal that tells you, hey, these are the potential causes for that. So for instance, it could be an anomalous behavior in a pump, and you have some contributing factors. So temperature is a contributing factor here, as you can see. And then you have to determine the causes based on the FMEA engine, failure mode effects analysis engine, to understand what's actually causing that. And the cause for that temperature is actually the bearing system, which may be jammed, that's causing friction, and that's causing temperature to go up. And that's when the advisory would be, hey, go inspect a specific equipment bearing. Right? This is where we're getting very targeted advice to the maintenance technician, as opposed to giving them broad range of suggestions. So FMEA libraries, rotating assets, of course, a bunch of assets, pumps, compressors, engines, motors, static assets, exchangers, furnaces, separator columns, etc. So these are things that we can look at and pull from the library and compare. Number 4 is the process automation area, which obviously in the enterprise space, been very popular for the last so many years with RPA tools in the market. But we're looking at things beyond that. We're looking at examples that touch production field workers, frontline workers, etc. So here is an example of work we did with Coke in terms of managing refill cartridges. So this, of course, is a customer service scenario where 11 steps, lots of spreadsheets, lots of repetitive entry, a lot of paper movement, APIs need to be built. So this is where we kind of use Power Automate RPA, which is part of a Power Platform that allows you to create the entire process automation. We had bots across SAP, Blob, and as SQL. Use AI Builder to process the invoices that are coming in, so scanning the invoices, extracting text out of them, eliminated Excel manual data entry, saved 10 FTs, and they were able to scale this to way beyond 50 orders that the per agent could support in the past. Nestle Waters is another example in the plant where is a great example of a person. His name is Derek. You can see his name on the right-hand side of the screen. He's also on YouTube. He actually is a high school graduate, not to demean that in any way. It's just that he looked at the application he was given to do plant maintenance, found that it was too cumbersome to use. So he just said, hey, can I do something better using Power Apps? And he used Power Apps to actually build all this on his own. Power Apps is a low-code framework. And he built all these screens where he could do defect tagging on the line. And now it's become widely used at Nestle Waters, 50 plus applications, safety tagging, loss map, center-line adherence. So this is where it's being widely used. You can see inputs, you can take an image, you can type in comments, and that's an example of what we've done with Power Apps. With Lego, again, a similar story where they moved from a complex Excel spreadsheet to moving to a very simple Power App that allowed them to capture all this data. So many examples. We have BASF, we have a tire company in Korea, we have a paint company in India, lots of customers using Power Apps across. I think in Australia also a number of examples of big and small companies using that. One example is how do you connect plant maintenance from SAP and integrate the whole thing. As you know, PM is a commonly used application in many manufacturing environments, but also not very easy to use. So your options to create a Fiori interface as an example, but could you do something better? So this is where you might look at creating an app that you can see in this particular screen, and then using that to push PM notifications, and then use that to drive Power Automate UI workflow. Then RPA creates the data, pushes that push the information back into the SAP PM notification. The maintenance manager then looks at those tasks and then starts assigning them. They get pushed to a facility team. They review those notifications, work lists, check status, mark them as completed, right? So this is how the entire process kind of flows from a red box, which is Power Apps, Automate, SAP Connector. The green is the SAP manual process, and the blue is the Power Automate and UI flow. So it gives you the complete end-to-end integration. So this is really powerful when you have to connect multiple systems together using a low-code framework as a front end. Now, of course, we also have the ability to do that through Teams. So this is where I'll talk about the digital worker and how we're kind of enabling them for remote work, for health safety, learning, knowledge management, modern devices, etc. So one example is how we looked at Arla, how they maintained all their assets during COVID using HoloLens and Microsoft Dynamics capability. So let me play a quick video.
Microsoft Teams empowers the world's frontline workers in manufacturing with the tools they need to stay connected, digitize workflows, and virtually collaborate with the right experts. Joshua Van Buren is a factory operator at Northwind Traders, a manufacturing company that provides its workers with shared devices. When Joshua arrives at work, he signs into a shared device to start his day in Microsoft Teams. Teams has been configured with the tools he needs to be productive for his role. Joshua clocks in to start his shift in Teams. Shifts is integrated with Northwind Traders' workforce management and time and attendance systems, so everything is connected in one easy-to-use place. Teams also provides Joshua with easy access to all the latest information in his pinned channels. He can easily chat with coworkers here and see the tasks he's been assigned. Joshua's first task is a routine inspection for pumps in production line 1. The inspection task includes all the details for the work item, including a link to an inspection form which has a checklist to maintain equipment on the factory floor. Joshua discovers a leak on pump 7, so he indicates the failure by taking a picture of the issue and uploads it to the form. As soon as the form is submitted, an incident work order is automatically created using Power Automate to follow up on the repair. For further insight, Joshua accesses troubleshooting files and equipment manuals within Teams. He can also go into Asset Manager in Microsoft Lists to get historical context about the pump, all without ever leaving Teams. Upon discovering that a new part is needed for the repair, Joshua uses walkie-talkie in Teams to confer with his supervisor, Kaji Bell. He uses push-to-talk communications to have a quick conversation about an approval request.
We need a new part to fix pump 7.
Okay, please submit the request. I'll approve it now.
Great, sending now.
Kaji can approve the necessary permits for the new machine part using approvals in Teams. She prioritizes the work order as urgent, assigns it to an available technician, and schedules the repair. Technician Will Little receives the urgent maintenance ticket for the assigned work order. But before beginning the repair, he wants to make sure the right electrical circuits are shut down. Will uses shift-based tags to search for an expert on shift to consult with. He connects with Eric, an electrical expert based at another site. Using a RealWare hardware device with Teams integration, Will shows Eric the wiring. Using hands-free video calling and with Eric's remote assistance, Will disables the right circuits and then begins the repair. When the work order is completed, Will shares best practices for the repair in Yammer communities. Joshua sees the post just as he is about to end his shift. He posts a comment to express his gratitude for closing out the task. Before ending his day, Joshua checks shifts within Teams to view his upcoming scheduling. He can also request open shifts, time off, or swap shifts with a coworker here. Joshua then clocks out and signs out of the device. When signing out of a shared device, Intune and Azure Active Directory clear all of the company data, so it's safe to be handed off to the next operator.
That was an example of how we kind of embedded Teams with a whole number of activities that can be done through a single interface. Of course, Power Apps can also be embedded into Teams. With mixed reality, there are a number of scenarios: remote assistance, training, custom guidance with data that's coming in. So there are a number of videos on this. I'll skip them. They're public. They're also been around for a while. So we'll skip that. We also work with some of our other partners in terms of, for instance, this is work we've done with Tulip in terms of pushing digital work instructions to customers, to operators. So this is where you can think of it as a lightweight MES. This is, of course, for a pharma manufacturing scenario, looking at exception management, looking at guiding and augmenting workers in terms of how do we do procedures, step-by-step procedures. Again, this is done through Tulip, our partner. Lastly, on security, the whole aspect of OT security is very critical. Example of an old attack, Triton attack on safety controls or controllers, tri-station controllers, how they actually took over the tri-station protocol, reprogrammed the safety PLC, disabled relief valve, and then created that that accident that we saw many years ago. So this is something that you can do where you can monitor devices in the plant. And as you know, endpoints, unlike in the IT world where you have Windows and Mac OS primarily, in the OT world, endpoints are from hundreds, thousands of vendors sometimes even. So how do you kind of manage that diversity of OT protocol and OT devices? So we can look at both the brownfield as well as greenfield network. So we actually do a monitoring of the entire network traffic. We don't have to be resident in any machine. We can even sit physically in the plant without having to be in the cloud. So a lot of plants are air gapped, so we can actually monitor OT traffic within the plant on premise. And then, of course, the dashboard, Azure Definitive IoT, which is the new name for the product called CyberX, and eventually connect back to central security dashboard Sentinel. So some examples where you look at how we're looking at asset discovery topology, whether it's an ABB PLC, whether it's a Rockwell Automation PLC, looks at the vulnerability of the Rockwell, tells you what are the severity scores for that particular device, whether there's a firmware change on a Honeywell controller, or whether somebody's introduced a new wireless router within the plant without anybody's knowledge, right? So these are all things that we try to monitor from a traffic perspective. So all the threats, unauthorized device, unauthorized connection, remote scanning, unauthorized PLC programming, and malicious commands. All of these things that we look at, we also have a group that monitors global PLC or OT device attacks, and that group sends warnings and notifications to customers saying, hey, and there's potentially XYZ vendor PLC that's being attacked, as you saw many years ago with the Stuxnet virus. So that was kind of a summary of the journey to intelligent manufacturing. Covered this from a very high level. Happy to deep dive at any point or take any questions as they come. And with that, I will now hand over to Lab 3 and take you to the next part of the session. Thank you very much for your time and look forward to working with all of you.
Thank you so much, Raj, for that very in-depth view around how Microsoft is really disrupting the manufacturing industry. With this time, I'd like anyone with any questions to please raise your hands. And what we will do is David will unmute your mic, and we may have a bit of time to answer those questions before we go on a quick 5-minute break. So if there's any questions, please raise your hand. Give it a couple of minutes. I think you've done an awesome job, Saj. You may not have any questions. And if we don't have any questions, guys, you can post them into the chat and we will either respond back to you on the chat or go back to you via email around what that answer is. With that being said, guys, we will take a quick 5-minute break, just so everyone can grab a coffee, and then we'll come back in about 5 minutes. So let's say 10:50, and we'll kick off with the next segment with Lab 3. Thanks, guys. Enjoy your break. Alrighty, guys. I hope everyone has had a quick 2 minutes to grab a coffee or the popcorn to hear the next speaker talk. So we might just kick off, guys. And please, again, with the next segment, please dive in with any questions that you may have. Either type in the chat, raise your hand, we'll unmute, and we want to make this as interactive as possible. But our next speaker, Alain Blanchette, will provide key insights that can help you build resilient and agile factories to enable reliable supply chains and enable an intelligent-driven organization. So I'll hand over to Alain to walk us through that. Over to you, Alain.
Thanks, Alan. Saj, great presentation. I've got some great insights that will align to this next presentation. Let me share my screen and get going. I thought I would start with a bit of an overview of who we are. LAB3 was formed about 5 years ago, and we grew up in DevOps. So the initial offerings that we brought to market were around infrastructure automation. I joined the organization about 3 years ago and started a data, AI, and IoT business. But I've come from a deep background in industrial data systems and looking at how manufacturers and other industrial customers can make use of their data. That pedigree of DevOps has really made its way into all of our offerings and sort of wove in the fabric of who we are today. And you'll see flavors of that as we go through this. In a nutshell, we have 6 practice areas. I won't focus too much on the other ones, but Saj talked about security a little bit. We do a lot of work in security for IoT systems as well, so that's worth noting. And the area that I work in, which is data, IoT, and AI, we focus on all the data platform work, but also have a deep set of knowledge in interacting with OT systems and bring them into the fold and allowing cloud technologies to be used to make decisions around industrial systems. So a lot of great use cases and case studies that Saj showed. And I think I see just a few types of optimizations if you talk about broad categories. And I'll go through a few of those right now. This is really at the core of what I would call continuous money being generated or continuous savings being generated. It's essentially looking at the way that equipment or the value chain of a manufacturing operation is run and operating it closer to its maximum throughput. And I've seen AI being used in a few organizations to achieve this. Probably the simplest way to describe this is looking at making every shift your best shift. I think in the manufacturing sector, there's a lot of individuals that are at the end of their career that have really learned how to make the machines hum and deliver the best throughput. And getting that knowledge encapsulated so that the next generation that comes in can run those machines and those production lines the same way that the best operator does is the key to sustainable manufacturing throughput. And we do that through a number of ways, but essentially data is king in this world. We ingest data, we look at what the best shifts look like and try to teach it to the AI. But realistically, you'll need to understand and benchmark how your operations are going before you attempt to make a change. And that's where things like OEE come into play. We've done some work around OEE and measuring OEE at manufacturing sites. But essentially, it allows you to figure out, where are you bleeding time out of your manufacturing equipment? What's causing downtime events? What's impacting the quality of what's being manufactured? How many rejects are you getting? And once you have those metrics, it's easier to make decisions on where you should focus your energies, where optimization should be focused. And like I said, there's a few types of optimizations. If you're getting a lot of downtime events, then something like predictive maintenance or vibration analysis might be worthwhile activity doing. If you don't have a lot of downtime events, but you feel like the machines aren't being run to their fullest, then looking at something like predictive control might be more appropriate. In reality, PLCs and the baseline controls, they're there to protect the machines, make decisions, and where data can make a difference, and some of the technologies that Saj was talking about is more in the advanced process control. And that's essentially looking at the incoming data, but more from a pattern point of view, rather than an individual decision for equipment movement. The long and short behind this is to capture the data, put all the measures and estimations into the ML model, and then feeding that back into the manufacturing ecosystem. And that helps with planning and scheduling, but also making sure the optimization on the machines are run in line with your best shift. We also do a bunch of work in vibration analysis, things like fast Fourier transform, where you're looking at the frequencies that are coming out of the machinery and how best to identify those machines before they fail. Fast Fourier transform and frequency analysis is a very specialized space, and Microsoft and a lot of other providers in the market have done a lot of work to help with that. This is an example we did for University of Adelaide. They're looking at acoustics, which is a form of vibration, to predict and identify when pipes burst or when there are events on the water network. I'd like to think that the ecosystem of these kind of models is really growing. There are companies like Uptake and others in the market that have published models for specific types of equipment, and those can be embedded in any of the data systems that Azure is delivering on. In fact, we've delivered some of those, so we embed third-party models in a lot of the work that we do, because it is a very specialized space. And so it's really important to get the right model rather than developing models that might already be there in the market, because the cost of developing net new models is high. So where possible, it's better to acquire them rather than build them. Now, this is an example of a more complex set of optimizations. This one comes out of the mining sector, but it applies to most manufacturing activities. We're essentially ingesting, in this example, a bunch of different data sources. So number one, they had cameras looking at the ore size coming in. They had data about the types of ore that was coming into it. And then we built an AI model hosted within a gaming engine. So like the physics around the machinery and the ore and the rock were all modeled in the gaming engine. And then we attached an AI model to that and gave it levers to change the settings, and also a feed of what's going right and wrong, like how quickly the ore is going through, and is the ore body getting crushed to a size that is desired. Importantly, because this is heavy equipment and equipment that is very, very expensive, we need to focus our energies on creating that digital twin that Saj talked about, because playing with real machines, big ones in mining, you don't want to do that at an early stage. You want to have the model being developed and trained in a virtual environment. And once you get those learnings, once the model is trained, you can deploy that into the physical environment. But it is a reward lever activity where the AI tries to constantly optimize the throughput and get the model trained up and ready to productionize. I'm going to show what that actually looks like. So just give me a minute here. So this is the simulation engine. It's multi-model. So that's which means it's got models that simulate the ore body. It's got models that simulate the crusher itself. I think all in all, there were 7 models running in this simulation to be able to train the AI. see the top bit is the camera of the incoming ore and ore quality. And the AI is moving all the levers and optimizing this to the best of its abilities. And eventually it gets to the point where its throughput is maximized. And that's really the goal of all of these activities. It's maximizing throughput or identifying faults in the equipment. In a general sense, I always say to manufacturers, go after continuous money rather than money that shows up sometimes. And by that, I mean things like predictive maintenance or identifying a downtime event. That's a sometimes event. And the benefits can be large. But if you can find something that is continuously being optimized, that is returning investments 24/7 like this is, the returns are typically much higher. And as IT professionals and technology professionals, that has a lot more weight inside of a business when you can deliver that kind of money. I think there's a lot of pie in the sky, really ambitious things that we talk about in the IT sector. You know, when you talk about the metaverse and getting virtual environments and digital twins stood up, those are, I would say, at the end of the journey, when you've got all the data flowing into systems and where you can make sense of it and show it into this digital environment, but also derive insights from it. And I think the important thing to remember is there's a whole bunch of underlying capabilities that need to be stood up. And everybody's on a different point in this journey. Some people might have started already and have data coming from machines into a central environment. Others might have already put it onto the edge. But at the core of it, there's sensor connectivity. Those can be net new sensors. In a brownfield environment, you might have extra data that you need to make the model work or the decision-making function correctly. Or it can be connecting into existing sensors. Saj spoke about OPC Way. That's a really good example of how to get data off those systems. At LAB3, we have electrical engineers as well, so nothing really scares us. We can go connect directly into analog or digital sensors and start broadcasting that data, and I'll talk a little bit about how we do that later. But we also have all the frameworks to do data acquisition, data transformation, and returning set points back into the PLCs and control systems. Also, importantly, we have a reference industrial IoT architecture. Now, when I was saying before that we grew up in DevOps, we grew up in automation. And the good news for that is it makes solutions portable, as in we can pour our thoughts and energies and best practices, create automation modules, and allow us to bring that to bear on projects that our customers want to run. Obviously, as you deploy devices, you also need to think about device management. In one of my first projects I did in an industrial scenario, it was a mine site that was pretty far away. We had deployed something like 100 sensors. And we had foregone device management initially because it was a pilot and we wanted to get it done fast, but it quickly catches up to you. So it's really important to keep track of all the devices and make sure that you can connect back to them, apply new settings, apply new updates. And that's really, an edge story and also, firmware updates over the air. Security hardening is crucial. We've seen too many news articles of late where there's been data breaches. And because we work in the physical world, it's extremely important to keep an eye out for security. We've got tactics and ways of ensuring security, and I'll talk to those in a little bit. But keeping the security hardening, segregation of networks across OT and IT is crucial for that long-term security and viability of these solutions. And then there's predictive analytics, tell me when stuff is going to happen. And advanced process control is really dabbling into AI and ML and having systems being taught and then controlling the manufacturing equipment to achieve the best possible throughput. In a broad sense, if you talk about capabilities that are required in an organization, number one, you need to have industrial connectivity and operationalization. And that's typically not an easy thing to achieve. OT and IT are coming together now and are joining forces, but traditionally OT has been a very separate and distinct network capability and set of systems. There's also traditionally been OT technology professionals and IT technology professionals, but realistically in the market now that is converging into one set of capabilities. Edge processing is important because connectivity is not always guaranteed, and the amount of data that machine produces doesn't always lend itself to having everything go into the cloud. And so edge processing allows you to make decisions in a time window that is possible to affect the manufacturing outputs. They had an example in Saj's deck about a grain supplier doing image recognition on individual grains. You can't really do that all the way connected to into the cloud. You need to have that as a capability that's on the edge, because the amount of data and the speed of the decision making is very fast. And I'll show you different time window architectures that match that. If you want to dabble in data, you need to have your data platform sorted, data ops, ML ops, all of that needs to be ready and available for teams to use. If you're going to tackle deep data workloads or even just host models, you need to have the ML ops process nailed. And then there's real-time data processing. Think of IoT hub, event hubs, like the real-time data technology. Lambda architectures are very common, hot path, cold path. So those are the core capabilities. And the good news is that a lot of these capabilities, we can bring them to bear in projects through automation. So we have all of the predefined architectures sitting as infrastructure code, plus some code modules that allow you to achieve the outcomes across all of these different capability areas. I thought I would just tackle a topic that I get asked a lot, and there's a few of these, so hopefully leaving you with some insights from the field. The first thing I wanted to bring up is, where should logic run when you're trying to do an agile manufacturing or any of the workloads that Saj was showing? There's a lot of decision making that has to be made around what is the correct layer within the OT, IT technology stack to make those decisions. In a general sense, all the IT componentry is used to teach the models, and bringing data out of systems to do the experimentation, R&D development, that for sure can be done in the cloud, and there are technologies that can be applied to bring that data out. The more you go down in this stack, the faster the decision making can be made, but also it requires more controls and more frameworks to make sure that you can deliver, update, and manage those workloads all the way down the technology stack. This is, a Purdue network. I'm sure people who've played in OT, who've been in the manufacturing sector, you've seen this. It's essentially OT, DMZ. You'll see things like your control systems, maybe your historians. PLCs are typically on the site, and they're like a smaller piece of compute that control equipment. And then there's field devices, think of sensors. Each of these layers can host various workloads around data and AI, or ML, or process optimization. Now, I really like this slide. It talks about how quickly the decision making needs to be made and where it should sit. And you can see here, like anything under a minute, you're looking at a closed loop edge workload. What does that mean? It essentially means that the compute that is next to the machine both ingests the data, hosts the model, and then can derive decisions that are put back into that same system. In the middle, you have near real time, and that is really getting closer to the OT network, still not in the IT network, as in it doesn't go out to the cloud for every decision. So it can lose connectivity, but it will synchronize back to the cloud once it comes back online. And all the way at the top, you have near real time and data lake integration. And that's really a cloud activity, requires connectivity. And the round tripping has a slightly larger time window. If I look at the decision-making horizons, I can see here like cloud near real time. You're essentially in the cloud. You've got your data acquisitions, data publishing, and data transformation modules running in the cloud. At edge near real time, you're in the corporate network, probably close to the OT technology that are in the DMZ, and decision making is made at that tier with infrequent pass-throughs to the site itself for compute. And in closed loop, everything happens on the site within that geography and does not require connectivity back to the cloud or even any of the IT systems. And that's where this last area is a very high velocity, short time frame for decision. We've also been dabbling a little bit in on-sensor AI, and that's relatively new. We came across it when we were trying to do a workload around vibration analysis at a site that had very low connectivity. We had deployed a LoRaN network, and for those who don't know, LoRaN is a very low bandwidth, although very low power as well, protocol, and therefore you can't send the full vibration workload through LoRaN. You can send the summary of it, like fast Fourier transform will just give you the frequencies that are moving around and which ones are getting bigger and smaller. And so we push the models for fast Fourier transform as in individual vibration readings being transformed into the frequencies down all the way to the sensor. In fact, this runs on the compute within the Azure Sphere chip, which is ultra low power, it's just a really interesting way to get closer to the vibration data without having to clog up with bandwidth and additional communication methods. This is ideal in scenarios where you have very long distances or a poor network already in place. If we bring all of this together, let's see if I can zoom in here. If we bring all of this together, the architecture will look like level 1 field devices, and those can be field devices that are on equipment or net new ones, and then levels of nested edge across each of the tiers of OT and IT. And that whole stack, depending how your network is set up, becomes your data acquisition stack. We have a bunch of modules that can do data acquisition, data transmission, and those can use OPC UA, MQTT, SQL. So there's just a whole bunch of capabilities that we can bring to bear to help do that data acquisition, data transformation on the edge. If you look on the right-hand side, you can see that there's a real-time portion and batch portion. That's pretty typical for deployment inside an industrial sector. Real-time data comes from the machines, and that allows you to make instantaneous decisions. It also allows you to branch it and put it into the data lake for further processing, things like doing AI or ML workloads into the future. This whole yellow area, we offer that as a service through our SensorMind product as well. So we can offer an analytics portal, the core data platform, and the real-time data platform as a service. And I guess that it comes down to how your organization wants to run these systems. If you want to build them, we can offer the frameworks and the automation to set it up on your own. But if you chose not to build it and you want others to run it for you, we have that on offer. Saj had some amazing demos with 3D capabilities within it. And I wanted to show you or give you perspective on how you can make that a reality and capturing 3D data. In our platform, we do a lot of 3D data visualization and digital twin capabilities that can be overlaid with some data. The 3D models can come from LiDAR and photogrammetry. For those who don't know, LiDAR is a point cloud technology. Think of laser scanning an area, and how fast the laser comes back determines the distance. It can be also overlaid with the coloring. So if you have the LiDAR and a camera together, you get these really cool models of LiDAR, but they're also, they have all the coloring for it. LiDAR is best suited for outdoors. Most of the LiDAR capture that we've done has been done with drones and in the power industry through helicopters. The point cloud data can be loaded, and then you can overlay pretty much whatever you want. Photogrammetry is essentially looking at more of a photo-based approach. So they take pictures and from various points of view, and photogrammetry essentially assembles that and creates this view of that specific place or object. Photogrammetry really lends itself to internal environments. So if you don't want to go create a 3D CAD model or some kind of step file of your manufacturing environment, we've got suppliers that'll go into your plant, and within a day you'll have a 3D model of that plant that you can use in your digital twin activities. We've also been playing with IFC and step files, and that's essentially just rendering existing CAD files or any of the design artifacts that you would have had when you put your plant together. It has a very crisp and easy to maneuver through UI. Saj showed some examples of that kind of design work being done. Typically, if you don't have them already, it's a bit of work to put them together. Like the model that I showed there in the mining sector, that took about a month of work to get all of the various elements rendered in a 3D space. But the great thing is, in some of these tools, you can also design the physics behind it, so you can use it as a means of training your AI as well. In all honesty, what I've seen the most of is integration into SCADA systems. And I think that's because you're not changing a lot of the behaviors and the way that the operations team visualizes data. SCADA has been around for a very, very long time, and so a lot of the operators understand this world very, very well and are very familiar with it. An example of how we've used this in the past, so if you look at all the data points from equipment, you'll typically have like the data point or the set point or the measurement next to that piece of equipment in the SCADA diagram. And we believe in doing advice before we do control, as in we offer operators additional data points as a means of improving their behaviors. Once it's been validated and those set points become the ones that they choose, we feel more comfortable than letting the AI control it completely. But that additional data point can be just put next to the data point that they're currently looking at. So for example, if you have a set point, you could have the recommended set point, and so they can compare that really quickly. The behaviors that happen typically will show the recommended set point for a while, and then they might not latch onto it straight away. But over time, they'll play with it and start using the set point, and it gives them comfort and it validates the model. And it's a great change management exercise as well, because you're not revamping, adding screens in the control room. It's where they've always worked in. I thought I would do a quick bit on wireless communications. And this is mostly for areas where you may not have traditional sensors in place. So if you're looking at more of a brownfields environment, or it's not somewhere where you've networked already. I know there's a few people from BlueScope and Matt. I think we've played with these, and in environments where communication is a bit harder, you can look at sort of battery powered, low power devices. Obviously, Wi-Fi is the highest throughput, or even plugged into your network, that's the highest throughput that you can get. But it also has some drawbacks, namely, you need to power that device, and that means electrical work and trades coming in to help do that. So Wi-Fi, big plus. Throughput is amazing, and you can get the granularity and density of data that you would like to have. NB-IoT and the sort of 4G networks are down one step as far as throughput and ability to deliver data at speed. And their power requirements are similar to Wi-Fi unless you turn it on and off, but then your velocity goes down. We've done a lot of projects with LoRaN. The data size is very, very small in comparison to the two others. But the big plus side is that you can battery power them and not do the electrical work or deploy them in environments where you just couldn't get power or comms. So it allows you to bridge that. Obviously, the challenge with very small data packets is that you don't get the density to do advanced models or possibly reducing down or stepping down the data quality that you receive from it. Or there are pros and cons to all of it. LoRaWAN has a range of, and we've dabbled in it all up to 40K, but reliably you can get sort of 10 to 15K, which is great when you're trying to cover a site or maybe a manufacturing plant. It lends itself to that. Wi-Fi is obviously a bit shorter, and you can pretty much put a 4G NB-IoT communication-based sensor anywhere you want as long as you have coverage. I just talk about our capabilities a little bit. So I spoke about some of the automation and how we go about delivering projects for our customers. At the core of it, we've got sort of a base platform and a reference architecture all built as code. And then on top of that, we've seen a lot of our customers not willing or not keen to stand up their own capabilities, and they just want us to manage it for them. And that's where some of our SaaS solutions come in. So I guess the real question is, do you want to run that internally, get your team stood up? Industrial IoT and smart manufacturing is a very specialized space. And especially in this market, it's difficult to find professionals that want to do that. Or you can buy it from us as a service and just focus on your business use cases. Might just do a quick overview of SensorMine and let you know what that looks like. Picture SensorMine as a managed service for the entire industrial data platform, visualizations, the data acquisition, batch-based processing, real-time processing, and a bunch of modules to get you connected back into your systems. We do have hardware as well, so we can go to data acquisition where it wasn't possible before. That really depends on the use case that you're trying to tackle. If you want to tackle something that doesn't have sensing yet, then that might be something you can look at. Has a whole bunch of API enablers, so we can connect to pretty much anything, including your business systems, OPC UA, PLCs, you name it. We've sort of got connectors for it. And we've got a full data integration stack, as I spoke to before, and a really epic set of UI controls. Everything from the CAD drawing rendering, so getting that really awesome 3D view of a plant. We've got maps and all the graphs you could possibly think of, so that's a really fast track way of building complex IoT solutions, all built on the Microsoft stack, all using the same technologies that Saj was talking about. And as I mentioned, we've got some hardware, and that's really about connecting to the source of that data. I thought I'd talk about a few examples. I know Saj showed a whole bunch of them, so I'm going to do a bit of showboating as well. This is actually time use analysis at a port site in the middle of Western Australia. So we deployed hardware to track the movements of the vessels. It's out in the open ocean, so they go out about 15 kilometers to ocean-going vessels from port, and they've got barges sort of in the middle ferrying that ore. So we did time use analysis, all the sensoring behind it, and we're moving into a phase now as we've acquired this data to do more AI-based scheduling of the assets. So I guess, like I was saying before, if you're doing OEE, time use analysis, uptime of equipment, that's the first phase. You sort of benchmark where you are today, and then we go into an optimization phase, and you can always refer back to where you were at the beginning to really outline back to the business how much you've managed to optimize that process. That is the fast version of what we do in this space. I would suggest that anybody that's interested in looking at optimizing their manufacturing activities, we do a IoT assessment, or ideation, which is essentially looking at all the various processes that you have, looking at your value chain, where the choke points might be, and how technology can enable greater throughput or better optimization or better prediction of downtime events. So for those who are interested in that, feel free to reach out to us and we can organize that.
Thank you so much, Alain, for that. And with that, guys, we've got 5 minutes left to go. What I will encourage everyone to do is, if you guys have any questions, again, we will unmute everyone's mic. So if you guys have any questions, please reminder to unmute yourself, to put your hand up if you'd like, and spit any questions out to Alain. So I'll leave it out to the floor. Does anyone have any questions? Another minute. Awesome, guys. Thank you so much for everyone's attendance today. Just to wrap up real quickly, what we will do is we will package everything up and send this out to the entire crew. What we'll also do is if anyone has any queries or questions post-event, please do not hesitate to either email the group, or alternatively, there should be a button which allows you guys to send us a quick note around any questions, and we'll definitely get back to you on that answer. But that being said, we will send out this recorded session out to everyone so that you can have a re-listen or review any other parts of the sections that you may have not have caught during the session today. On behalf of both Microsoft and LAB3, thank you so much for taking the time to listen to us talk a little bit about IoT and how Microsoft and LAB3 can really disrupt the manufacturing industry and ensure that your business drives better efficiency as well as profits throughout your business as well. Thank you so much, guys. We'll end it there. Thanks, team.
Thank you.
Thank you.